If a user provides some XYZ input, and which other part of the code will be executed if user provides say ABCD as the input. So based on the inputs of the user or based on some other situation, whatever you want, you need some way of discriminating the code that you want to execute. And that is the place where we need these flow control statements. Okay, so there are different types of flow control statement. First, we need to see what about this plain condition execution, or based on differentiating based on plain conditions. That given a condition, execute this part of the code, given the defined condition, execute other part of the code. This we want to understand how it can be done in C programming. And if you know how it is done in C programming, believe me, you can do the same thing in all other programming languages. This basic construct is same in all programming language. Okay, because if you want to provide a programming language, I mean, in computer science, people will be doing research. Perhaps some of you will be doing research, and at that time, you'll be also feeling that maybe C programming is not enough. You need some more facilities to provide some more use to the user, some more ease of programming. Okay, in that case, you need some better way of doing all this branching, all this decision making process. So in that case, you can develop your own language also. But if you define your own language, you'll have to satisfy some basic criteria. Like the programming language should provide what are the basic things that it should provide. This conditional flow is one of the basic things that a programming language should support these basic facilities. So if-else statement is one of the very fundamental components of this programming languages. Okay, in C statement we'll be seeing how it is done in C programming language, but it is similar to other programming language also. Loops are there where we repeatedly execute, as we had in the tutorial yesterday. That loops allows us to repeatedly execute a piece of code block. So that is also conditional flow, as you can imagine. That in conditional flow we want that some part will be executed or some part will be skipped. It is not only that, but also it includes that some part will be repeatedly executed. That is also conditional flow. I mean, you are actually controlling the flow of the program execution in this way. So some part is there based on some input pattern, it will repeatedly execute, or based on your requirement, based on your need. Okay, you don't need to write the code multiple times manually. Okay, you want that the computer should itself execute this part of the code, say 100 number of times or 1000 number of times. So these all are basically conditional statements. Okay, so loops are there and plain conditional statements are there. We'll be seeing these two types of conditional statements in the next slides onwards. This is the plain if conditional statement where we have this keyword if, and then test expression is one of the I mean, this is the base based on which you are actually going to differentiate whether this some part will be executed or not. As we discussed just now, that through this if-else condition or if statement, what we do is that we try to differentiate, right? We try to decide that based on a certain situation, which part of the code will be executed and which part will not be executed. So in this particular if statement, based on this condition which is provided by this test expression. So test expression provides a condition. Based on this condition, within this second brackets, curly brackets, whatever statements are there inside these curly brackets will be executed. So how it will be distinguished? Definitely we'll have to check whether this test expression is true or false. If it is true, then within this curly bracket part will be executed, otherwise it will not be executed. So this is one possible way of doing this differentiation using if statement. So similarly, we have else part. We can attach an else part which is optional. So if statement and if-else statement are different statement, or you can also say that you attach else part with the if statement, it becomes a different statement, it becomes if-else statement. So in the else part, you can provide some extra set of code. So then things will be mutually exclusive. Mutually exclusive means what? That this condition within this if first bracket, whatever condition is mentioned here, this condition if it is satisfied, then within this second bracket whatever is there that will be executed. Otherwise, the other part, that is the else part, will be executed. So it's quite clear that there are two blocks of statement. Just see this whole program from using a very top view. Just have a top view of this whole program. Just divide this program within this main program, actually this main function. int main, and then second bracket starts and second brackets end. So here the second bracket is starting and here it is ending. I hope you can see my mouse cursors. It's not visible here.
Sir,
it's not visible,
sir,
unfortunately.
what if we do not?
Yeah, continue.
Sir,
Hello?
what if we do not put that curly bracket? Then how our program will be compiled?
Which curly brackets you are talking about? There are several curly
Sir,
brackets.
after if statement, that the printf statement
After
is
if statement,
between
curly
the
brackets are necessary. Yeah, after its if statement, curly brackets are necessary. But some situations are there where you can omit these curly brackets also. I'll come to that. Okay, I'll mention this point. When we don't, it's not mandatory to put this curly bracket. There are some special cases only. But for the time being, assume that we need these curly brackets. So curly brackets or these second brackets, as you know, these have some special importance in C programming. What is the importance? It defines a block. It defines a block of code. Okay, you define a block of code using this curly bracket. You can start curly bracket without any program also, without any statement also. Just start an arbitrary curly bracket and then end it. So that will become a block of statement. You can call that this is a block of statement. You can give a label also to the block of statement. So that is the reason C is also called block structured programming language. Block structured programming language. So it means that you can divide the whole program into multiple blocks using curly brackets. And that we are seeing also here. Like if statement needs a block of code, and that is defined here explicitly. This printf you entered -v number %d. This is one block of code. You can write multiple statements here also within this block. And similarly, in the else part, separate curly braces are starting and ending, right? So that also is defining a separate block. You can input multiple statements there inside. So these blocks are very important, very fundamental units of C programming. So now see this whole program and try to divide into multiple different blocks. How many blocks you are seeing there in the C program, in the overall view? From an overall bird's eye view, how many blocks you are seeing in the program?
So three.
Three blocks are there, correct. Basically, three blocks are there. One block, the first block is before the if else statement. Whatever things are there before the if else statement is one particular block, you can say, because they will be executed sequentially and all of them will be executed. Fine. After the if else statement is starting, how many blocks are there? Two blocks are there. One is within if, another is within else. So now match with the old statement that I made, that if else statement or if statement allows you to differentiate the execution or change the flow of the execution, that which block will be executed, which block will not be executed, that you can control using if else statement as well as if statement. Is it matching here? Here, out of these three blocks, one block is executed always, the first block. But the other two blocks will be executed based on the condition which is provided in the if statement. Number is less than 0. If number is less than 0, that is true, then the second block will be executed. Otherwise, the third block will be executed. So execution of the third and the second block is mutually exclusive. Either one of this thing will be happening, not both. Is this basic idea clear to everyone? So let us proceed. Now, as we discussed in more details on the last class, let us have a comparison between these two statements. So two separate if statements and one if else block are the same. I had a question last time that are the same. So the answer was that yes, they are same basically. So yeah, so why they are same quickly? Anybody can answer? How to check whether they are same or not?
Sir, because else means that if the previous condition is false, then the next block of code will be executed, and in the next slide the condition is that the first condition is false. So
yeah, so the way of checking is that you'll have to start with the condition. Which condition based on which we are differentiating? The condition is number less than 0. So how many variables are there in this condition? Only one variable, number. And you are basically deciding the condition or composing the condition based on the values of this number, the values of this variable number. Now check here, what kind of values may be there inside this variable number. It's an integer variable. Number is check, it's an integer variable. So number can be either negative numbers, positive number, or 0, right? So these 3 cases you'll have to check. So based on these 3 cases, which part of the code is getting executed in both of the codes? In version 1 and version 2, how these 3 possible ranges of this number is treated. So in this first case, just check number is less than 0. You have explicitly defined which block will be executed, and else means number greater than equal to 0. In that case only the else part will be executed. Correct? That is the opposite or the reverse of this number is less than 0. Else part means that number is less than 0 is not satisfied. That means the opposite part, number greater than equal to 0. Right? So you have explicitly defined which part of the code will be executed when you have number less than 0 and number greater than equal to 0. Right? So number greater than equal to 0, you don't specify here. That is the job of this else condition. If you know that there are 2 mutually exclusive conditions and based on which you can do 2 different jobs, you can easily use this if else condition. No need to specifically mention the condition again in the else part. Like this code we can also define by writing else if number less than equal to 0, then we do this. Okay, that is not necessary. If you do this, then also it is fine, but that is not necessary here. That is the beauty of this else statement. You can just do the mutually exclusive part in a default way. And here in this code, what you are doing is that you are explicitly defining these 2 conditions, and some code blocks are there. Just check the same piece of codes are there, same blocks are there, but 2 different if statements are there with 2 different conditions, and these conditions are also again mutually exclusive. Number less than 0 and not number less than 0. That means they are mutually exclusive. Either one will be satisfied. So the output of this code will be exactly same. Okay. Yeah, the doubt is clear. There is no doubt with anybody from the online people.
Sir, excuse me, sir.
Yeah.
In this code, why is the 7th line necessary, sir? Even without the 7th line, we can execute the code now.
7th line. 7th line is just a comment. It's a comment statement. So if any line starts with double slash, it's a comment statement. So comment statements are not executed.
Then what is it? Why do we write, sir?
Yes, so that's a good question. Those which are not executed, why do we write? Can anybody answer this simple question? Common sense question.
Sir, so that by seeing a code, we can understand it clearly.
Yes. So I mentioned these issues earlier. You can recall that the code that you are writing is not meant for you only to understand. Okay, so basically all of us are part of some team. When you will be working in some company, you will not be alone doing the company job, right? Many other people will be working also with you in a team. So it is very necessary that whatever you write should be understandable clearly to all other team members, or the people who are testing your code should be also understanding your code properly. Otherwise things will be difficult. Teamwork will be actually hampered. And similarly, when you leave the job, someone else will come for technology transfer to you. At that time, you have to explain all these things, and he may not be remembering all these things from verbally to you. I mean, just listening after verbally from you may not be able to remember everything, right? So it's your responsibility actually to write everything in the code with comments that you are doing this statement because of this. Again, all the codes are actually written to solve some purpose. What is the purpose? Solving some problem. So solving a problem can be done in various different ways. You can solve in one way. The same problem can be solved by some other person by some other way. So as you can recall that you can go to a particular destination in multiple different paths, right? Same thing. Solving a problem is reaching a destination, and that you can do by taking multiple different paths. Okay, it depends on your thinking process, your thought process, right? So based on that, you have done some coding which is working. Maybe not inefficient, maybe not that much efficient. Okay, some efficiencies are there, but yet it's working. So that you have done, but you have to explain that logic very briefly in small sentences using this comment statement. So that's why comment statements are very much important. So what compiler does is, when compiler sees some sort of comment statements, it simply removes the statement before compiling. Okay, it simply removes the statement automatically before compiling and then does the compilation job. This is called pre-processing part of compilation. So compiler does one pre-processing step where it removes all the comment statements and some other jobs also there. Okay, when you'll be studying about compiler, if you are CS people, then you'll be studying in details about how compiler works. So there you'll be seeing what are the steps in which compiler works. It's a very complex operation. So very first step is that to remove the junk material. So remove these comment statements and then start the compilation process. I hope that is clear why you need this comment statement, the line number 7. Let us proceed further. Okay, so just to extend this, we had this if-else ladder. So we may have multiple expressions, multiple conditions. So one condition you have seen, number is less than 0. That's a very simple rudimentary conditions. But imagine that we have multiple variables. Okay, user is providing multiple different values to multiple different variables. And you want to take your decision based on these different values of the variables being provided by the user. Okay, just for an example, imagine that there are 3 variables. Okay, A, B, C. These 3 variables you are taking from user. And in that case, user may provide different values of these 3 variables. You don't know what kind of values are being provided by going to be provided by the user. But your decision should depend on these 3 values. So how many combinations can be there? There can be many possible combinations. Just imagine, can you give me one possible condition based on these three possible variables? Anybody? Any conditional statement including these 3 variables or consisting these 3 variables A, B, C, integer variable.
A plus B is less than C.
Yes, simply you just think about A is greater than 0, B is greater than 0, C is greater than 0. So when all 3 numbers are positive, you'll have to do some operation. Imagine, be imaginative. When you have 3 variables, you have many options possible. You can develop many conditions. One of the possible condition is what? A greater than 0, B greater than 0 and C greater than 0. And all these conditions are ANDed together or OR together. You have 2 options there also, you can recall from your relational operations. You can use OR operation to join or you can use AND operation to join. Correct? So there can be numerous possible situations. You can create various situations. Say you want to develop some program which will sort these 3 numbers. I think you have already gone through this particular problem, sorting these 3 numbers. So sorting means what? Sorting means you have to find out the relationship between these 3 numbers, right? So sorted order explicitly means that you have to write an order of these 3 numbers, A, B, C. You have to write these 3 numbers order, but this order will be different based on the values of these 3 numbers or values of these 3 variables. If the first variable is lesser than the second variable and the second variable is lesser than the third variable, then the ascending order will be. So A is the least number, least possible values. A is less than B and B is less than C. So then what is the order? A, B, C, right? The ascending order. So A, B, C, this ascending order is coming because A is less than B is true and B is less than C, that is also true. Correct? So this order will be different when these conditions will not be true. So in case A is greater than B and B is less than C, the order will be different, right? So you'll have to write this, print this order based on these values that are provided by this user, ABC. Correct? So these orders you have to decide. You'll have to enumerate all possible relationship between this ABC. And based on each of these relationships, you'll have to print the orders. So how many possible relationships may come? You can easily compose an if-else ladder. If A is less than B and B is less than C, you print an order. If A is greater than B and B is less than C, you print a different order. If A is greater than B and B is greater than C, then you print a different order. So all possible combination, how many possibilities are there? Just apply combinational theorem. So
6.
this 6 possible situation you'll have to explicitly mention. Then you'll have to write all these explicit orders. Is that clear to all of you? You'll have to mention this. Computer doesn't understand anything by default. You'll have to explicitly create these orders and mention what should be printed in case each of these orders are satisfied. Okay, so such type of situations you can handle using this if-else ladder. There are multiple orders, multiple conditions, and all conditions have a relationship between them because all are using same 3 variables A, B, C. So now there is a very important situation, very important issue that you should understand, that basically this C1, C2, imagine there is an if-else ladder where the first if-else ladder is the first condition is starting from C1, and then else if C2, then else if C3, and then statement 4. So there are 4 statements, okay, or you can think of 4 blocks of statements because curly braces are there, right? So these blocks of statements will be executed based on the conditions which are mentioned here, C1, C2, C3, and C4. There is no C4 here, but you can imagine there is something C4. When C1, C2, C3 all are false, then C4 is coming. That is a C4. So just try to understand the flow of execution of this if-else ladder first. And then try to convert it to equivalent individual independent if statements. If statements are independent, but if-else ladder is not independent. Else part automatically provides the mutually exclusive part. Right? So in this case, just focus on this if-else ladder. If we provide the condition C2 there, else if C2, then it means that C1 is false and C2 is true. So when C1 is false, then only execution will come here in this else part. Otherwise, it will not come here. Okay? So C1, C2, C3, C4, sorry, C1, C2, C3, these things will be tested in a sequence. First C1 will be tested, then if it is found to be true, then statement 1 will be executed, and then the full if-else statement will be skipped. No other statement will be executed. Keep in mind, if C1 is true, then only statement 1 will be executed, or you can say in this block whatever is there that will be executed, other things will be skipped out. But if C1 is false, then execution will come to check, or control will come to check whether C2 is true or not. If C2 is true, then statement 2 and other statement in this block will be executed, and the other part like C3, statement 3, statement 4, all these things will be skipped out. So if-else statement always provides some sort of mutually exclusiveness, right? Some sort of mutually exclusive property it actually implements. So any of this statement 1, statement 2, statement 4, either one of these will be executed, not more than one. Is it clear to all of you? Only one of these statements will be executed, statement 1, statement 2, statement 3, statement 4. But if you write if block separately, independently, then you have a freedom. Okay, but if-else ladder you don't have a freedom. If you make a mistake in forming these conditions, you may be in trouble basically, because only one of these statements will be executed. Say you are thinking that maybe multiple statements will be executed, should execute, but ultimately it will execute only one. So you have to form this C1, C2, C3 very carefully. Otherwise there will be mistake. So it is basically much safer to use single standalone if statements if you are not confident about. Say you know that if this condition is satisfied, then this part should be executed. If this is not satisfied, then what will happen? I am not sure about it. In this situation, you should use only the if statement. So just check the equivalent if statement will be what? If we want to simply use if statement, no else part will be there. Then we should try to understand. Remember what we are trying to do. We are trying to find out the equivalent statement of this if-else statement using simple if blocks. No else part will be there. So in that case, we just need to check when statement 1 will be executed. Statement 1 will be executed only when C1 is true. There is no other relationship with C2, C2, C3 or any other condition. So we can simply write if C1 is true, execute statement 1. So this is the Simple. The first one, if C1 then statement 1. So this is a simple execution of statement 1. It's independent of anything. Because we know that if C1 is true, then definitely statement 1 will be executed. If C1 is not true, then C1 the statement 1 should not be executed. And that is quite true. It's happening also in the second equivalent part also. Correct? Now if C1 is so just now second question is what? When statement 2 will be executed? Statement 2 will be executed. Just check from this if-else ladder. Okay, so just check from this if-else ladder when statement 2 will be executed. When C1 is false and C2 is true. That is the only situation when statement 2 will be executed. Don't think that C2 will be true, then only it will be executed. It's not like that. C2 has to be true, but along with that, C1 has to be false. You cannot ignore this first part. Okay, so if we want to write independent if block, then we'll have to include both these things together. If not C1 and C2, then statement 2 is executed. And the same thing for the statement 3 also. Okay, I will not continue anymore. Just let me know if any doubt is there. This equivalence, if else and if statement. Is it clear to everybody? Online students?
Clear.
Yes. Yes.
Okay.
Yes.
Sure.
Fine. So if we write this one, just a simple variation, this is correct. Okay, this implementation is correct. Equivalent if blocks is correct file. But if I write this one, then what will happen? Yes. So forming the condition is something very important. So when you have some set of conditions, you'll have to write down the conditions in your pen and paper and study a little bit that how you can minimize. Like this code is doing the same work as your initial if-else ladder, but you're writing much more and making it complicated first of all. Just imagine if each of these C1, C2 are basically bigger statement, contains multiple variables, say 4 variables are there inside each of these C1, C2, C3. Then you are making it complicated. And it will be definitely harder for the next person to understand that what you have written. So when you will be writing code, everyone listen very carefully, when you will be writing the code, imagine that your TAs are basically the next people to whom you are transferring your technology. So they should be feeling ease in understanding. You should not write something very complicated and make your TAs very surprising that they are not understanding it. You should not make such situation. This habit you should grow. Writing a complex statement is not a matter of credit. Writing simple statements, doing the work that you need is the matter of credit. You should always try to focus writing simple code. Okay? And obviously this is simple code. If-else ladder. This part is simple. And this if statement, although this is easy to understand, but it is complex statement, I would say. Independent if statement. Okay, that's why first you have to understand the conditions very well. Try to understand there is some mutually exclusiveness in the conditions. If there are some mutually exclusiveness in the condition, then do use if-else ladder. So you should not write the conditions haphazardly. You have to do some study over the conditions and try to understand which part is mutually exclusive than the other part, and then separate it out in if-else statement. Okay, so these basics are basically not there available in any book. Okay, if you see Kanitkar's book or any other book in C programming, you will not get these things at least. So that's why attending class is very important. Interacting with the teacher is very important. Okay, just search if anybody find these particular issues, that mutually exclusiveness. I'll be covering some more issues also, but these are something necessary. You have to make it clear when you should use if-else ladder, when you should use nested if-else statement. There are few issues which you should understand properly. Okay, so this code is very easy. You can easily write a program to test whether an integer is odd or even. You can easily do that. I'm not going through it. Just check the code quickly. I'm printing this statement and then taking the number and differentiating based on a new condition. Number %2 is equal to 0. Okay, so number %2 is the condition and the variable is numbered here. The values of the number will be deciding the condition output. Correct? So based on the number input from the user, number %2 may be 0 or it may be 1. If you divide a number by 2, then the result will be either 0 or 1, right? So here you can simplify this condition also, as we discussed last time. The number %2, if we simply put there, that means if we just omit this equal to 0, like equal to 0 is a relational operator, you can recall, right? So relational operator definitely you can use to make it clear that you want this to be an even number. If the number is even, then you execute this printf %d is an even integer. This printf statement you want to execute only if the number is even. You want to do that. You can achieve the same thing by omitting the double equal to sign. Will it work? If I simply omit the double equal to sign, it will not work. Why it will not work? Because, yeah, so when you remove this double equal to sign, the value will become 0. When we want it to be executed, the value will become 0. So we want to make the 0 to 1. How we can do that? Using a not operation. Simply add a not operation over that. So when number %2, when not number %2, then you execute this even number. And when that is false, that means number %2 equals to 0, then number %2 equals to 0, then it is even number. And if in case it is not of not is what? Not of not is again the same thing. So number %2 is equal to 1 in that case. It will come to the else part. So imagine this simple modification. Wait. So if I were to simply remove this, then this is wrong code. It is not going to work. Correct? This is the opposite thing it is doing right now. Okay. We want to make it correct. To make it correct, we have to add this not operation. Now somebody tell me, will it work without bracket? Here again comes the question of precedence and associativity. There are two operations here, not operation and percentage operation. Please anybody check the book and tell me if you cannot recall. Not operation has higher priority than percentage operation. So that's why. Is it correct or wrong? Just check properly. If you think that not operation has higher priority, then not number will be executed first and then %2 will be executed later. So not number will be doing what? It will not work in that case. So somebody check the table.
Yes, sir. Not is before. Yes, sir. Not is before.
Yes,
Sorry?
sir. Yes, sir.
Not is before, sir. Not has higher priority than percentage.
So then what you should do?
Yes, sir.
If not has higher priority,
Not to put
then
brackets.
we must include a bracket.
Yes, sir.
So we want that this thing should be executed first. Right? Otherwise there will be problem. Be very careful about all these issues when writing a code. So in any case, if you have confusions, for example, you are not recalling properly, what you will do is that add brackets. Because when you are writing an expression, you have something mental setting that you want that this %2 should be done first and then the not operation. But you are not sure whether what will happen if you don't include the bracket. So include the bracket. There is no problem in that case. Okay. So there is no need to become clever in that case unnecessarily. That yeah, I am providing not operation, it will happen automatically. But it may fail because you are not sure about it. And if you are sure, then definitely you can put it. But questions will be there in your end semester, mid semester, as well as your any interview also, that what will happen if I don't provide this bracket? What will be the output? Something like that. Okay.
Sir, how the output will give output will come by number % to not?
Not getting.
Sir,
Repeat your
how
question.
the out, sir, what it means that number percentage to not, what it means?
Okay. So recall two things first of all. Just try to recall what this not operation does. Not operation is what kind of operation first of all? You have learned operators, right? We have gone through our operators very thoroughly. So what kind of operation is not operation? Not operation. What category of operation is it?
It
Sorry?
simply change the output from true to
No,
false.
I'm asking what category of operator is not operator? It's a logical operator or relational operator or mathematical operator. What kind of operator is it? It's a relational operator or logical operator?
Logical.
It's a logical operator, right? Clear, everybody? This is
Yes.
logical operator. So logical operator will have to treat its input in a particular way. We discussed all these things in class, you can recall. We are proceeding step by step. So logical operator, if you provide some operands and the operand is not a relational operator, if the operand is not basically true false, then the operator will interpret these operands as true false. So in case of not, if you provide some non-zero number, for example, if you simply write not 2, if not to execute something, what will happen in that case? These are very basic things. You just try to make it clear. Confusing things will be there, but you'll have to understand these things, right? I explain all these things. So if I write simply like if not 2, okay, so do something execution. So what will happen in this case? So no, what will happen first of all? 2 will be interpreted as a non-zero number. That means it's a true. And not over 2 is what? False. So if false, nothing will be executed. Because if false is coming as an execution, as an evaluation of this condition, then this if condition will not be executed. This part will not be executed, right? So the same answer here is also in this case. Yeah, so in this case, if number percentage 2 becomes 1 or 0, what are the possible options? Number percentage 2 will be either 0 or 1. If it is 1, that means what? That means not of 1 is 0 in that case. So it's a false operation. So when it is odd, it will become false. So in that case, odd number will be executed. The second part, else part will be executed. It's correct. That we exactly want. And when number percentage 2 is equal to 0, not 0 will be 1. That is true. In that case, printf percentage even number will be executed. That is fine. That exactly we want. Correct? Fine, everybody?
Yes, sir, got it.
Okay. Okay. So we can actually study these conditions in this possible way also. Okay, so let us look into this if-else statement, nested if-else statement a little bit, and after that we'll be talking about the other parts. Yeah, this is an example of these mutually exclusive conditions. So this is again what? These are independent if statements, right? Independent if statements. And each of these if statements are basically mutually exclusive. The conditions are mutually exclusive. If if the value of number is 4, it cannot be 5 or 3 or 2. Any one of these will be executed basically, right? So here, if we write if or if else, the output will be same basically. Just check carefully. The output will be same if I use if else or if, isn't it? So believe me, this if else and if else ladder and nested if else, there will be many confusing questions to you. You'll have to play with the conditions only. You'll have to understand quickly grab the relationship between the conditions. So check these conditions here carefully. All the conditions. Yeah, come inside. So how will you do that? So you'll have to call the roles or what?
Yeah, we can do that, and maybe we can circulate the sheet and I'll update in the line.
Yeah, but where is the sheet? You have a can somebody just lend a A4 size paper? Basically, collection of this attendance is very difficult right now. Okay, but you'll have to collect it. So one TA will be there in every class. He will be collecting the attendance from you guys. Okay. So anybody just take a sheet and put your signatures there. So fine, do it in a transparent way. Fine. So just interesting part, note down here that if and if else, if we have this particular setting, in this case, all these conditions are mutually exclusive. Fine. So that's why we can use if else condition here also. If I write an equivalent if else statement here, it will be same output. Based on the value of the number, things will be same. And recall in this last example where we converted from if else to if else statement, just check the difference between these two outputs, these two equivalent statement, if statements. What is the change here? So here, in case if and else if, they are working appropriately fine because these statements are mutually exclusive. That's why you can replace if by if else. No problem is there. But in case they are not mutually exclusive, you cannot use if else statement as an exchange. You cannot replace if by if else statement if they are not mutually exclusive. So just for an example. So if I write if the number is 5 and 4 or 4, if 5 or 4, then this particular condition has the relationship between relationship with this number equals to 4. Also part of this condition, right? The second condition, just look into the second condition, number is equal to 4, and the first condition. First condition is what? Number is equal to 5 or number is equal to 4. So these conditions are not mutually exclusive. If one is true, then the other will be also true. And in both the cases, we have some exclusive outputs. We want something to be printed. So in this situation, you have to use if. You cannot replace the if by if else. If you use if else in place of this if here, it will be wrong output. Because if else will allow you to print only one of these blocks. But if independent if statement will allow you to multiple blocks can be also printed without any problem. So be very careful when you are playing with the condition. You should be very sure that the conditions are mutually exclusive. Then only you can use if else statement. Otherwise, you have to come back to if conditions, independent if statements. So this is a just pictorial example that what kind of conditions you should think of. That when these things are mutually disjoint conditions, basically just isolated conditions. So in that case, you should think of these are very easy. When isolated conditions are there is no relationship between one condition and another condition. Things are easy to handle. Okay, you can use if else statement, if else, whatever. It doesn't matter. But if there are some intersections are there, say condition 1 is true, in that case condition 2 may be also true, and in that situation condition 3 may be also true. Or there are some part when condition 1 and 2 are true, but condition 3 is false. So when such complex situations are there, you should be thinking carefully what should be the right way to implement. Okay, so let us talk about these two particular words, syntax and semantics. So syntax means every C programming statement or any language, there are some rules set up. For example, in if statement, what is the rule? You'll have to first write the first bracket and then put the condition there, and then second bracket starts. Within second bracket, you'll write the statements. So these rules are the condition. It's called the syntax of if statement. So syntax will be there with every possible statement. There will be some syntax associated, right? And the other part is semantics. These two words will be encountering many times throughout these lectures. Okay. So in the semantics, we think about what is the internal meaning of this particular statement. Semantics means internal meaning, or what is the output that are going to be produced by this statement. Basically, why you are putting this statement. So if the semantics is clear to you, then now you will be deciding properly that which statement you need here. Okay. So semantics means the core meaning, and syntax means how to apply the rules to make it correct, so that compiler compiles it properly. Okay. These two are different things. Keep in mind. You are writing the semantics properly. You know the semantics properly, but your syntax may be wrong. And similarly, your syntax may be correct, your semantics may be wrong. So you have not understood what is the use of this particular statement, but you have used it. Compilation is working. If your syntax is correct, compilation will work, but it may produce wrong output because your semantics are not clear to you. Okay.
Sir, semantics is the code.
Sorry? Semantics is more related to the logic that you need to develop before writing the code. Before writing any code, you need to develop a logic, that what is the logic through which you will be making the code successful, right? You need to achieve a goal. That goal will give you the logic, and the logic, based on the logic, you have to decide the semantics, that which semantics you need to borrow. Like if else has a semantics, if statement has its own semantics, it should be independent. So you should know the core meaning of the statement that is related to semantics of that statement. And syntax is basically how to write it, so it becomes correct. Compilation is successful. Example, just find out the result of comparison between two integer numbers. That you can easily find out. I don't think it will be problematic for you. So in two numbers, there are three possible relationships. So you write three possible exclusive statements for that. Now, how you will join them together? You can write independent if statement also. There is no problem. In case independent if statement also, only one will be executed. Correct. So is it clear to all of you when you should write independent if statement and when you should write if else blocks? When you know that things are mutually exclusive, then we can join these different conditions together in a ladder, if else ladder. But when you are not sure about this mutual independence or mutually exclusiveness, we should use independent if else statements. So here we know that these conditions are mutually exclusive. When number 1 is greater than number 2, it cannot be equal or it cannot be less. So that's why you can join them using if else ladder. There is no problem about it. Yeah, come to this nested if else statement. So nesting is coming. The concept of nesting in case of if else statement is coming because of this non-disjointness of these conditions. So different conditions may have some overlapping part. So if you want to handle this overlapping part in a common way, in the common coding, then you need this nested if else statement. So just take a different example. Nesting, this particular word nesting, you'll find frequently actually in programming. So nesting means that, I told it in the previous class also, that nesting in general means you include or you place one statement inside another statement. So you can print, you can put a loop inside an if else statement. You can put if else statement inside a loop. You can do many other nested structure. You can create a nesting structure. Okay. So here we are basically focusing on nesting of these if else blocks or conditional nesting. Okay. So how we can nest if else statements within each other and solve some complex problem, that we are trying to focus. So where we need this nesting in case of this conditional flow. So nesting is necessary. Let's take an example. Let us discuss with this example only. That imagine that this number 1 and number 2 we are going to compare. Okay, and we write a broad level condition first. That number 1 is greater than or equal to number 2. So now number 1 is greater than or equal to number 2 has two parts basically. Number 1 may be greater than number 2 or number 1 is equal to number 2. So for each of these two parts, you have two different statements to execute. But both of them can be joined using a higher level if statement. Okay, using a higher level if statement that we are writing in the beginning. It doesn't matter. You can remove this if statement also. If you just remove the higher level if statement, it will not also affect the performance or affect the output of this program. Will it affect? I can simply remove the just broad level thing, outer level thing. So, but just try to understand, this is called nesting. You are doing what here? you are putting an if-else conditional statement within an if statement. That is called nesting structure. We'll be coming to that when we need it. But this is not an example where exactly we need it. This is just an example where how we actually construct this nesting of nested statements. So if statement, this if part is independent part. This part is basically independent, and this part which is inside this if statement, that is also independent. These two are different statement basically, and we are nesting one statement within the other, and that's why it's called nested statement. Fine. The reason why we are calling nesting, this is clear to you, and this is syntax also. We'll have to follow it independently. This if has its own syntax, and this if else has its own syntax. They should not interfere with each other. In any nesting operation, the nested part and the nesting part should not interfere with each other. They should be independent fully. Okay. Only thing is that we are including one statement inside another statement. That is happening here. Now let us try to understand why we need it. Okay. Yeah. So this is the else part. Else part of what? Can you just check carefully which else part is there? I mean,
Sir,
which
the outer
else
else
part? Yes, so that is the outer. Because return 0 is there. This second bracket is basically the second bracket of the main function. It is not the outer if. It's not the second bracket of the outer ifs, because return 0 is there. Okay. So this if statement also has an else part, and that is this else part. Okay. Any doubt with anybody? There should be some doubt perhaps.
Sir,
If I don't use this
sir,
nesting operation here, yeah, what is the query?
sir, if we put a printf statement inside a if statement, will that also be called nesting?
No, printing statement inside the nested inside is it's not nesting operation. It's not nesting. It's definitely not nesting. So
Sir,
nesting
but
needs a
nesting,
conditional flow. Where is the conditional flow happening? For example, if you want to nest a loop inside an if-else statement, that we call nesting operation. So we have already studied about loops in the last class. You can recall, if you take a for loop and put it inside the if statement, that will become nested loop. The loop is nested inside an if statement. So you have to bring some sort of conditional statement to include inside another conditional statement. Okay, I mentioned that it's a general statement. It's not a general statement basically. If you just include some conditional statement inside some other conditional statement, then we call it a nested statement. Yeah. Okay. So in general, it's called nesting operation. So check this diagram. So this is the outermost condition, the blue part. So in the outermost loop, we have one condition, right? And the condition will be true for certain cases. So this outer blue circle is covering all such cases when the outer condition is becoming true. Okay, and out of that, inner condition 1 will be true for some subset of the cases. Okay, so in these cases, if you want that, let us first do a broad level pruning. Okay, pruning means what? If you satisfy some conditions, kind of a pruning. You are coming to a specific cases, set of specific cases, and now there may be some common operation for all the specific cases. After doing this common operation, you make some more fine-tuned conditions, and then you do some more operation inside the outer condition. So in this particular hierarchical organization, if you have some hierarchical conditional organization, in that case you need nesting operation. Okay, so when we need nesting operation, when we have some inherent hierarchical organization among the conditions, in that case we need to use this nested if else condition or looping condition or any other nested operations. Okay, so let us take some more examples. There may be complex situation like this also. Okay. Yeah, somebody asked me that what is the use of these brackets. So here we understand what is the use of this bracket. So after if we don't have multiple statements to execute, we have a single statement to execute. For example, if A greater than B, then printf hello world. If we have this type of situation, only single statement is there to execute. In that case, we don't need any bracket. It's same as if A greater than B, printf hello world. Okay, we don't need any explicit second bracket or curly braces. We don't need that. But if we have multiple such statements, say we want to print two things together, some more operations are there. In that case, bracket is must. Okay, it's a very trivial difference that if we have a single statement inside a block, then we don't need the brackets. If we have multiple statements, we must have a bracket to distinguish the other parts. Okay, so by mistake, if you don't provide the bracket, what will happen is that the if will be associating only the first statement. That will become wrong, actually, logically wrong. Okay. Okay, so we'll be starting a different topic right now. Let me know if you have any doubt or any other issue with the if-else condition or conditional things before we proceed.
Sir, if we are putting a for loop inside a if statement, that is also called nesting operation, but the for loop is not a conditional statement.
Yeah, for loop is obviously conditional statement. It's a special conditional statement. It's a looping operation is there. It's a loop. For loop is loop, right? It's a loop, special type of loop. So loop always allows you to take a decision to go back to a previous location to execute. So it's obviously a
Yes,
conditional.
sir, I got it.
Okay, so
Yes, sir.
now we'll be starting this condition, this issue of this algorithm. What is called algorithm? Okay, this word algorithm will be finding several times, many times throughout this course, and CS people will be going through a separate course also called data structure and algorithms, as well as design analysis of algorithm. There are some separate course for CS people. So algorithm, what is basically meant by algorithm? So algorithm is basically the sketch or the blueprint of your solution for some problem. So you need computing systems because you need to solve some problem. That is a basic requirement of the computing system, right? So now if you want to solve a problem, you cannot solve it haphazardly. You need to have a logic behind your solution. So very first step is that you form your solution steps. That what are the steps you should follow to solve a problem. So this set of steps, when you write in a very systematic way, that is called an algorithm. Algorithm is not a program, but a program is extracted or is an outcome from an algorithm. So algorithm is first developed. From that, you convert that algorithm to the implementation code or the program. So first you have to think of an algorithm, whatever problem I give it to you. Just for an example, you want to print or you want to mention to the user that you have entered a negative number, you have entered a positive number, or you have entered a odd number, even number, whatever. Okay, or you can also write that you have entered an odd and negative number, you have entered an odd and positive number, something like that you can mention also. So based on if you want this outcome from computer, you'll have to write some set of steps, set of code. But for writing this code, you'll have to plan very well first. What you should do? Just for an example, take this example. You want to print out whether a number given by the user is odd or even, as well as positive and negative or zero. Positive, negative, zero, as well as odd and even. These two things you'll have to print out in a simple program. What will be the steps? Can you just find out what are the steps? You all can do that quickly. Write it in your code, in your book, notebook. What will be the simple set of steps? Write in a way that number one, you should do this. Number two, you should do that. This way you should complete. And at the end, you have got the outcome, right? So can you form your code in this way? Can you form your algorithm in this way? Algorithm is basically a set of steps, as you know already. Just try to write it, everyone. So where you will start? How you will start it? You will start from the input process. You'll have to take some input from the user. So take the input, that should be your first step. Take the input number from the user. This is your first step, the very first step. Without taking a number, you cannot check. So using scanf statement, you can use that, but that's an implementation of the algorithm. It's not the algorithm. Algorithm is just take the value from the user, and its implementation in the code will be scanf statement. So in the algorithm, just write take the input from the user. Second step should be what? Second step should be you should start checking. So you have to form the conditions. So how the conditions will be formed? You already know how to check it negative, positive. You already know how to check it whether it is odd or even. Now we need both the things together. So you can do it in multiple ways. As I said, that people will be thinking in different ways. You can do it together or you can do step by step. So if you do the simpler possible way, that you do step by step. So you first check whether the algorithm is whether the number is negative or positive or 0. Print that value, print that thing. So that block will be outputting that this number, your number is negative or your number is positive or your number is 0. Fine. This will be the output of the first block. And inside that block there will be some if-else statement. Second set of block will be what? Just check for odd or even. This simple step you can do, right? You can easily find out this simple set of steps. So first step will be input your number. Second step will be check whether this is positive or negative or 0. Output it is positive if it is positive. Output 0 if it is 0. This way you can write the steps. This first set of statements are over. Next you check whether it is 0 or it is odd or even. Now if you want to write some sophisticated outcomes, say if you want to write you want to write a nice English statement based on this combination. You want to do it together actually. How many conditions will come in that case? So in case of odd even, there are 2 possibilities, odd or even. In case of negative, positive, 0, there are 3 possibilities. Fine. So then total how many possibilities will be there? We'll have to analyze the conditions. Try to analyze the conditions. Are these conditions mutually exclusive or they have some relationship between them? They are not related. So they are independent basically. So you can easily multiply. There are 6 possible conditions. And each of these 6 possible conditions should have specific statement.
Sir, only 5 are possible, no, sir. 0 is.
Yeah, definitely. You can fine tune these things, but try to understand an overall idea. Try to get an overall idea. You'll have to club together these conditions if you want to do in that way. And then you can simply use an if-else ladder. So from here onward, you just try to think of first. Provided any solution, any algorithm, any problem is provided to you, start thinking. Multiple options will come in front of you. First option we discussed, that you first solve the odd even issue and then solve the positive negative issue. Or you first solve the positive negative issue and then solve the odd even issue. This independently you can solve. Second step, we are trying to combine these 2 things together. So in that case, you can think of an if-else ladder. So if you want to use if-else ladder, then you have to form the conditions in a mutually exclusive way. So first the number has to be checked with %2. Number %2 is equal to 0. That means it is even number, and number is greater than 0. That means you can simply write the printf statement. Your number is even and positive. So this specific statement you are able to output because you have tested explicitly that this number you have entered is basically even number as well as a positive number, right? This way you can continue and build your other conditions one by one. Clear to all of you? Now, how to use nested if-else statement if I want to make it optimized, if I want to make it further optimized, how to make it nested if-else statement for this particular issue? So you should understand that there are algorithmic issues, obviously. Algorithm is about thinking about your steps, right? But these steps are ultimately influenced by the set of programming constructs you know. If you know that there is an if-else ladder, then you will think your algorithm in that way. If you know that there is a facility of nested if-else statement where you can prune down some of the operations and then we can come to fine tune hierarchical organization we can make, then you will think in a different way. Or if you know only about independent if statement, then your condition thinking will be also different. So definitely there is a feedback mechanism you can imagine that algorithm development is not independent. You will have to know the construction facilities. Then that will be giving you a better algorithm perhaps. Isn't it? This feedback loop always goes on. You know better way of programming that you use to develop your algorithm. But all these things where any solution you can build up, you can develop to get the outcome is called an algorithm. Now here comes the question, is the algorithm good algorithm or a bad algorithm? Maybe you don't know enough programming constructs. So in that case, your algorithm will be actually poor. So it will be rudimentary writing, just check it whether it is even or check it is odd. But if you know some if-else statements in a ladder form or in a nested form, you will be writing a better algorithm definitely. Where less number of operations will be there, many things will be lesser, optimization will be there. Okay. So things are basically highly related. So basically we need to know that how to write these algorithms in a very systematic way. So there are some ways to write this algorithm in a systematic form. We also called it a flow chart. Okay, some rules are there. It's a very easy topic. I'll be going through very quickly. Okay, so check in internet or check in your book what is flowchart, how you can represent an algorithm using a flowchart. So flowchart has some rules. For example, this oval is for using to start and stop, indicating start and stop of the algorithm. Then this rhombus or this parallelogram is used for taking some input, okay, or producing some output in the screen, or taking some input using scanf. You can use this thing, this sign. So go through this sign first. Processing block will say you are using some operation, A is equal to A plus B or B is equal to C plus D. This type of steps you can write inside this rectangle. Okay. After this rhombus or diamond, you can use for decision making, that you check a condition inside this. Okay. And based on this output, you'll have to take these different directions. I'll come to the example and show it. Circle is just for connecting. Say multiple different paths are joining together in a same, then you can use a circle for that. Flow lines are there. Yeah, example. So draw a flowchart to input two numbers from the user and display the largest of these two numbers. Simple example, let us see it. So this is an example. You take a input, start is the oval, and then take input using this parallelogram, input 2. Then you just check using this diamond, that number 1 is greater than number 2 is not. Then if it is true, then using one path and coming to display the number using parallelogram for outputting, and then coming back to the circle, and in the other case display number 2 and then also coming to the circle. So this is joined here and then things are stopped. Very simple example. Just go through this example. You have gone through already perhaps in your 10 plus 2 or 10. So another example, I'm not going through this, spending time here. So let us keep these things. You go through it. I'll be sharing the slide. The slides are shared. I think these slides are shared already. Yeah. Yeah, things may be complex also a little bit. As the problem will become complex, then your flowchart will also become complex. Okay. So from this flowchart, what do you think? This flowchart is basically influenced by what kind of looping, what kind of conditional statement? Just check. Yes. So we are doing some hierarchical if-else condition, right? So we are first checking this if A greater than B. This is the first condition we are checking. Based on that, we are taking two possibilities. One is false, one is true. And in each of these cases, we are using another if-else statement. So is it nested or is it ladder?
Nested, sir.
Nested or ladder? Nested? Cannot do it using ladder. Why? We cannot call it mutually exclusive because different variables are used. The set of variables are different basically here. in A greater than B and B greater than C and A greater than C. So the first condition is A greater than B, and then the other conditions are B greater than C and A greater than C. So think carefully whether we can call it, we can use nested, or we can use only, I mean, we can use if else ladder, or we are only bound to use nested statement. Think carefully and let us discuss once again in the next class.
Sir, it is nested only, no?
Sorry?
Sir, it is nested, no, sir? Because under one if condition, we are placing another two conditions, no, sir?
Yeah, so why can't we add it using else statement? Say if A greater than B, then if it is true, then you can check another thing. Else if A greater than C, and in the else part, if it is true, inside that you can, yeah, this part will be definitely else, definitely nesting part. So fine, I'm not, I'm not arguing here. You can draw it, you can make the code, you can form the code from it and play with that. Like try to make it nested, try to make it ladder and check where it is actually coming true. These experiments you have to do on your own if you really want to learn. Otherwise, I am going to point out here the things. Okay, I'm not going, it's not possible to hammer on these issues again and again because there are so many things, but I'm going to point it out. But if you play with these things, try to check whether a nesting will be operating correctly here, or we can also use ladder statements. Okay, these answers, if you can unambiguously, if you can find out on your own, things will be very good for you. Okay.
Okay.
Same thing is here. It's a flowchart for finding the roots of a quadratic equation. Okay, it's a very common example. Okay, you can similar thing you can expect in your mid semester also. Okay. Flowchart will not be given, but you'll have to draw a code also, and the final code, the full code you'll have to draw. So this flowchart drawing operation is just to aid your thinking process. If you have a visualization of the whole logic, this is the visualization of the whole logic, right? So if you can do the visualization properly, then definitely you can write a good code. If you cannot visualize, then definitely there is some problem in your thinking. Be very careful about it, and that you should refine where the problem is coming. Okay, so we'll be touching another way of doing this decision statements or flow control, that is called switch case statement. Okay, so switch case statement is another way of doing this decision making or flow control. Let us see what is the flow chart or what is the syntax. Okay, so every statement has its own syntax, okay, which is different from each other. If else statement has its own syntax, like if this keyword has to be there, then first bracket should start, and then you should put the condition, and then first bracket should close, and then second bracket should. This is the syntax of if else statement, right? For switch statement also you have a different syntax. What is the syntax? We write this switch keyword first. This is the keyword. I recall every word in C programming has its name, right? It's a keyword. Those names which are reserved are called keywords, and those names which are actually defined by the users may be identified, right? They're called identifier. You can recall that. So switch is a keyword. Okay. So keyword followed by expression. This expression you can build up based on your requirement. Now this expression will be evaluated as if in if statement things are evaluated. The first bracket, within first bracket, whatever is there, that is evaluated first. Here also things will be evaluated. Rahul, what about the online people?
Yeah, taking your argument.
Okay. Then you are going to add all these things in the spreadsheet, right? And from that Chandra will be uploading it.
So can I leave?
Yeah, definitely. When you are done, you can leave. No need to ask me or make it transparent for you. Okay.
I have another question. So for next week, should I take attendance for 3 classes or like?
You come in the middle. Come in the middle, take it for 5-10 minutes and leave. No need to sit for the whole period. Okay? Make it transparent and convenient for you as much as possible.
Sir, and during spreadsheet there is, 2 columns for the same date. Is it for 2 hours or like 1 hour, 1 hour lecture?
Yes, basically that you should copy it. Okay.
Okay, sir. And for the Thursday lecture, there are 2 hours class, but then only 1 hour, 1 column is specified for the
Thursday we have how many hours? No, we have 1.5 hours or there. Same thing are there. So just a minute. Okay, so they have done They have split up one class, 1 hour class into 30 minutes, 30 minutes there. Take only one of the classes. What should be done for that?
So can we take only one attendance session? However, I am coming in the middle of the two lectures. So maybe we can have
Yeah, but for the record purpose, you should keep both. So you can add another column here, okay? Make it two, like Thursday class and as well as Tuesday class. Both should be two, okay? But you put the same thing, right? And make it convenient for you. You can convey this information to the next year also.
Yes.
Yeah. So this switch case operation, switch case statement is basically an equivalent of what? Can you just guess? Equivalent of if-else ladder basically. Okay. So just it's an easier way of implementing it. You just write this switch operation, switch keyword, and then expression. This expression will have multiple values. So this expression will be evaluated to multiple possibilities. So this expression will be first of all evaluated and then the value will be extracted from the expression. So note that this is an expression, it's not a condition basically. You can put condition also. In that case, the expression will evaluate to either 0 or 1. But you can put an expression here. The expression may contain multiple defined values. It may have all defined letters as an output. You can simply put a variable here. The variable is also an expression, you can recall. So whatever variable value user puts, based on that things will be executed. So it is, you can say it's a modified version of if-else condition. In if-else condition, when people wrote about, researchers designed the if-else condition, they understood that if-else is a very generic thing. But in programming, often we need to differentiate our code structure based on the inputs of the user, by the user, or the exact outcome that is coming from an expression. So based on these defined values, you may need to execute different statements. So how to do it easily without going for if-else statement or that conditional problems? Because in if-else statement, you can easily make some mistake. If you have some overlapping condition in if-else ladder, then your things will not be executed properly, as you understand correctly. That if-else statement in if-else ladder, if you somehow make a mistake and then make two statements say overlapping with each other, then definitely this intersection part of this overlap statements, overlap conditions, what will happen? Either one of them will be executed, both of them will not be executed. But since the condition is true for both of them, in some cases, it should execute both. Basically, you should not use if-else ladder in those cases, or you should define the conditions properly. If you want to avoid these complications, then you should go for this switch case statement. Because in switch case statement, you have this mutually exclusive situations always. This expression will be evaluated to multiple different possible values. And for each possible value, you can provide a case here. So for example, case constant 1, case constant 2. So if the value of this expression, evaluation of the expression happens to be constant 1, then this statement will be executed. The meaning of this is that. Okay, so it's a special case of if-else condition, if-else ladder, right? With some ease of operation. You take an example, it will become clear to all of you. Yeah, just for an example. So imagine that user is going to provide a value, some arbitrary value, some number. And based on this number, we are going to print different statement. You can do it using if-else ladder also, right? If user provides number is equal to 2, then provide you have given 2, number equal to 3, number given 3, this way you can provide. But if I want to do the same thing using switch case, what you should do? Put this number in the switch case expression part. Then number will have different values. Based on these different values, you define the cases. Case 7 means value is 7. You are writing your own statement here. You can write your value is 8. For 7, you can write 8 also. You are free to write. That will be a wrong outcome, but your code is correct. Same thing in case of 8, you are writing 8. 9, you are writing 9. And then for the other cases, you are writing out of range. Okay, so you are going to print something for 7, 8, 9. You can write an if-else statement ladder also, but this is easier. This is the more convenient way of writing for C programming. Okay, so you have to understand why we are putting this break statement and why we are putting this default statement. So cases are basically the particular condition, that expression, the num, the variable num equals to 7. Case 7 means num equals to 7. The equivalent condition is what? Num equals to 7. Similarly, this is num equals to 8. These are the equivalent conditions if you write if else statement. Okay. So default means that if you don't have, if none of the cases are matching, basically none of the cases are satisfying, in that case what will be done? In that case, this default statement will be executed. And break is what? Break means after execution of this case 7, rest of the statements will not be executed. That is explicitly mentioned by this break statement. If you miss the break statement, what will happen is that if it matches with 7, then rest of the statements will be also executed until it finds the next break statement. For example, if I remove this break statement from here, and if you provide the output 7, input 7, what will happen? It will printf value is 7, printf value is 8, then break statement is there, then it will come out. These way things will execute. Anyway, we will just see some more example in the next class. Okay, and next class we will also talk about loops. Yeah.
So why we had to assign the value like in num equals to 8? Is it necessary to do that?
No, it's not necessary. You can take it using scanf also. Okay, let us stop here then.